Hi, my name is Arthur Stanley Eddington, and I am a British physicist, mathematician, astronomer, as well as astrophysicist. I am studying solar eclipse to see if it has evidence which would point to validation in Einstein's theory of general relativity. I'm studying the solar eclipse in order to see how light deflects around the sun's gravitational field, or if it does at all. So if you were trying to see if the light would shift due to the gravitational field from the sun, it would prove that mass and matter kind of confined to the curvature of space, and vice versa, which really calls for a very complicated set of loop of mathematics, since you have the curvature dependent on the mass and energy of everything in it, and then that's dependent on the curvature of space. So it's just a constant loop and motion of mass and energy, and kind of this would, in order to take pictures of these star clusters around the sun while there's an eclipse, it would really point to whether that light was being stretched around by that gravitational pull from the sun. And well, we did this experiment off the coast of Africa, West Africa, and we took pictures of the stars out there in an island called Principe in the Gulf of Guinea. Well, during this time, Britain and Afghanistan went to war, making it the Third Anglo-Afghan War. The Treaty of Ganmark was actually violated when the current ruler, Nasrullah Khan, attacked British forces. And this was just about 23 days prior to me coming on my expedition. I received help from my colleague Frank Watson Dyson. He is a British astronomer who is remembered for introducing time signals. Now, these time signals were used for broadcasting and radio broadcasting, and it was a way of these 6 1-second intervals were a way of calibrating when to start radio broadcasts. In this project, I did most of the taking the pictures of the stars around this eclipse and gathering that empirical data which would point to Einstein's theory. Now, the reason it's empirical is simply because I'm taking these pictures and I have no way to model it yet. Once it's modeled in either a set of equations or some other proof, then it can be widely more explained. Well, Einstein even said that one of my books was probably the best way that relativity could be explained in another language. And honestly, after taking pictures and gathering this data of the light bending around this gravitational field, I was able to further my understanding on relativity and model that so generations below me would be able to further that. Like I said, it just kind of, in a nutshell, the theory of relativity, its premise is that the curvature of space-time is determined by matter and energy contained within it. And so you have the light particles, which are these matter, and the curvature is dependent on it, but also these light particles are dependent on the curvature. And so you have the energy from the gravitational pull and the particles of light that are all dependent on the curvature of the universe. but the curvature of the universe is also dependent on the matter and the mass and energy. So it's really a headache when you get down to it. But so maybe my greatest contribution to science was a headache, but in all seriousness, it did help explain how the universe works instead of a linear fashion, which so previously was accepted. But as you are able to further develop technology and understanding and realization on things, it really gets down to in the everyday world, Newton's law of universal gravitation is perfectly good approximation of this, the curving of light. But in the idea of special relativity, all the energy, including light, have a mass, and so it seems like light would pass through a massive body like the sun. It would feel the tug of gravity bent on light. So all in all, all this data goes to show that the universe was no longer how we thought it was. And my contributions, I'd say, were mainly contributing to Einstein's in the sense that it's not a linear fashion. So the theory of relativity would be more widely accepted. Next, I plan to get knighted and further my study on the mathematics and behind Einstein's theory of relativity. All right, thank you.